This example isn't too heavy on the function stuff, but I think it's a nice way of combining together loops and functions in one example. So it's pretty intense. It's a good review exercise if it's just before the midterm or something, or if you just want some reinforcement for tracing in general. So first off, the file is posted, so please take a look at it. The point of an exercise like this is a practice question, so please try tracing it yourself. But I will go through it step by step. Hopefully you've given it a try first, because if you watch the video, you might be spoiled on what weird things happen. So let's start tracing. As with any other C program, the first thing we execute is main, so I'm going to draw a scoping box for that. I'm only expecting a few lines of output. I'll put them up here this time. I, of course, know in advance how much output there's going to be, so I'll just make a small box for that. So let's draw a scoping box for main. Because space is a bit of a premium here, I'm going to eat into the area used by the code itself. Okay, so main has 4 variables it declares at the beginning, all ints. So there's int, and it is x, and then int y. And then on lines 19 through 21, we assign values to all of them. And then on line 22, we want to do a function call. I'm just going to clean up my boxes a little bit here. We want to do a function call. So the first thing we do to call a function is we sub in the values of our actual variables, 7 and 12. So we're calling f with the values 7 and 12. So it gets 2 arguments. Of course, the first thing in the brackets becomes x, and the second thing becomes y. So we're about to call the function, and so we set up a scoping box for it. Over here, outside of the scope of main, we set up a scoping box for f before we do anything else. And this example, I think, unlike the previous examples, maybe provides a better illustration of the process. I eventually want to start executing code at this point. Before I can do that, before the function is allowed to start, we have to follow this procedure. We have to finish the call. So we have to create a box on the diagram for every one of the arguments to f. So it takes 2 arguments, int x and int y. Before the function can start, it needs to have values for all of its arguments. And once the function starts, once we start on line 2 and begin executing, those arguments, x and y, are just regular local variables. The only reason that they're special is that they get a value before the function begins executing. But we could change the values of x and y, and in fact, we will in a minute. So I'm still calling the function. I set x to 7. That's the value of the first thing that I passed in. And I set y to 12. Now that I've set up the scoping box and I've given the arguments their initial values that were passed in, now I can finally begin executing my code at line 2. So line 2 says create an int called z inside this scope. So there's z, int, and it has the value 10,000. And then on line 3, create an int called I. Oops, it's getting a bit in the way, and give it the value 0. Now we're at line 4. It's a loop, so good review of loops here. Is x less than y? Okay, well, x is 7 and y is 12. And so the answer is yes. So the answer is yes, which means I go inside the loop. X equals x plus 2. You might remember that this is a shorthand assignment operator. And you are absolutely free. If you ever see one of these in code that you're tracing, you could just, cross this off and rewrite it as x equals x plus 2. It is identical. But maybe it's nice to learn how to read them just the way they are. So x equals x plus 2. In this scope, x is 7, so x equals x plus 2 means that x is now 9. Here we have y equals y minus 1. Okay, so that means that y is now 11. And I equals I plus 1. That means in this scope, I gets the value 1. We go back around, we hit the closing curly bracket, and we go back around. You might have noticed I didn't make a scoping box for the while loop in my diagram. Maybe that was cheating a bit. I knew in advance, because I looked at the code, that there's no variable declared inside that scope. If you don't declare a variable inside the while loop, you're not going to have any scoping issues. You could just ignore and not create the scoping box. You might want to do it anyway, just in case. But in this case, I was maybe cheating a bit because I knew in advance I wasn't going to need it. So I go back up, ask the question again. Is x less than y? Well, yes, x is 9, y is 11. So we go down, hit line number 5, and on line 5, x equals x plus 2. Well, that means that x has now got the value 11. Y equals y minus 1. Well, okay, that means y has the value 10. And then I equals I plus 1. So I has the value 2. We go back up, ask the question again, is x less than y? And the answer is no. And so we head down to line number 10, and we generate our first line of output. In f, let's see, x equals, and we're inside this scope here still, x equals 11, y equals 10, and z equals 10,000. And we don't print out I. It turns out the value of I was sort of useless to this point, but we'll notice on line number 11, the next line, we do use it. So return the value of I. So what's the value of this expression I? Well, it is, finish erasing this, it is 2. So that means we're returning the value 2. So we take the value 2, we sub it in where the call to my function originally was, and then we destroy that scope. So I'm growing increasingly fond of this, being able to circle stuff like this. That's lots of fun. We destroy our scope. We actually sort of, maybe we'll clean this up a bit since I like circling stuff so much. There we go. Oh, I don't know what happened there. Maybe I won't do that. We destroy our scope. We go back to main, and now we assign the value 2 to the variable result. Gets the value 2, and now we're here. And you might have noticed, in the meantime, none of those variables in the scope of main got changed. And that shouldn't be too much of a surprise, because a minute ago, we were sitting inside this scoping box here. And we know that when we're inside a scope like this, the only things we actually have access to with the features we know about right now are whatever's in this scope and whatever's outside this scope. Nothing in other scopes. Now, you keep seeing that I gesture about what happens if you go outside the scope of F. We'll get to that. We're 1 or 2 videos away from seeing it. It actually isn't very exciting. But it is possible to have variables sitting out here in the strange wilderness outside of all functions. And when we see an example of it, you'll notice that it sounds extremely spooky and interesting, but it isn't really that spooky or interesting. So we get down to line 24. We print our output in main. Oh, and I better, for the sake of argument, I drew this box. I better get rid of that. In main, let's see, x equals 7, y equals 12, z equals 0, and the result equals 2. So the function executed, it did some stuff, it printed some output, but at the end of it, the only thing that escaped from the wreckage when the scope of f was destroyed was that return value. All of these variables that f owned, they were all obliterated when the scope was destroyed. And as I always say, because I just love to congratulate myself for doing this, because I drew a diagram, it wasn't too tough. The diagram took some time, but it saved me a whole ton of thinking and a lot of ways that I could have made mistakes.